Hello friends, I am Anil Agrawal. In this video, I will discuss a few basics of refraction of light for CBSE class 10th. Refraction is a phenomena of bending of light. When light travels from one medium to another, we know that it bends. This bending of light is basically due to the fact that light travels with different speed in different mediums. Since the speed changes, and actually it is as per Fermat's principle of least time, light follows that path for which the time taken by the light to travel up to a particular point will be minimum. Anyway, for now it is enough for us to know that light bends. This bending of light is called refraction. Now here first we must define that what do we mean by rarer and denser medium. A transparent medium which has more mechanical density is said to be optically denser. Thus, if we compare air to vacuum, air is denser because the density of air is a bit more than vacuum. If we compare hot air and cold air is denser because the density of molecules, density of matter in cold air is more. That is, a medium which has higher mechanical density and is transparent is said to have higher optical density. This optical density is also called refractive index, Ri symbol mu. So the mu of cold air is more as compared to hot air. To give you a data, mu of vacuum is considered to be 1.000 and mu of air is considered to be 1.0003. When we call A mu g, this is read as refractive index of the glass with respect to air. With respect to air means we are treating the refractive index of air to be 1. So A mu g, the refractive index of glass with respect to air is 1.5. Similarly, A mu w, the refractive index of water with respect to air is 4 by 3, 1.33. With respect to water, refractive index of water with respect to air means we are treating air as the base, 1. We can also define refractive index of glass with respect to water. Now with respect to water means if the refractive index of water is 1, then what will be the refractive index of glass? So if we are talking about W mu g, it will be mu g by mu w. That is, it will be A mu g by A mu w. That is, it will be 3 by 2 upon 4 by 3. A mu g upon A mu w is 3 by 2 upon 4 by 3, that is 9 by 8. So the refractive index of glass with respect to water is 9 by 8. Anyway, I am more interested in discussing the changes during refraction. Just to say it all in one simple sentence, I will quote as one of my favorite dialogues that when light goes from rarer medium to denser medium, everything decreases. Air is rarer medium, glass is denser medium, the refractive index of air is less, the refractive index of glass is more. When ray goes from air to glass, it is going from rarer medium to denser medium. And according to me, everything in denser medium decreases by a factor of mu. The wavelength in medium, lambda m, is equal to lambda air upon mu. It is the frequency which remains unchanged for some reasons. Everything else decreases by a factor of mu. Velocity in medium is equal to velocity in air upon mu. Similarly, sine theta in denser medium is equal to sine theta in air upon mu. It means that as light goes from rarer medium to denser medium, say from air to glass, the angle formed inside the glass, which is the denser medium, will be less. Here of course we know that the angles are measured with respect to the normal. So what I mean to say is that the angles, the sine theta and thus the theta will be more in the rarer medium, and sine theta, that is the theta, will be less in denser medium. So when light is going from air to glass, we will say that ray has bent towards the glass. The ray bends towards the normal. As the ray goes from air to glass, the glass is a denser medium. The angle formed inside the glass with the normal has to be less. Since the angle formed by the refracted ray inside the glass with the normal has to be less, we will say that as ray goes from rarer medium to denser medium, it bends towards the normal. Similarly, if ray goes from denser medium to rarer medium, we just have to remember that the angles formed in the rarer medium are always bigger. When ray goes from denser to rarer, when ray goes from denser medium to rarer medium, the angle formed in the rarer medium with the normal will be more. Say this is the boundary of the two media, this is the normal, this is the incident ray in the denser medium. The ray in the rarer medium will go like this. That is, when the ray goes from denser to rarer medium, it bends away from the normal. It bends away from the normal because the angle in the rarer medium is more. And remember, the angles are always measured with respect to the normal. I repeat, when ray goes from denser to rarer, the angle in the rarer has to be more. And thus, we can conclude that the ray has bent away from the normal so that the angle theta increases. I repeat, in denser medium, everything decreases except frequency. Frequency is something which never changes. Wavelength in denser medium is equal to wavelength in air upon mu. Here mu is the refractive index. Lambda m is equal to lambda a by mu. Vm is equal to Va by mu. And sine theta is equal to, sine theta in medium is equal to sine theta in air upon mu. I will also like to discuss the difference of these things with respect to color. That is, I will like to discuss what happens to red color and what happens to blue color. Red color has maximum wavelength, and there is a relation which relates mu with respect to lambda. That is called Cauchy's relation, C-A-U-C-H-Y, Cauchy's relation, and this states that mu is equal to A plus B upon lambda square. Anyway, as wavelength increases, mu decreases. Now the red color has maximum wavelength. The red color is used in danger signals. It has maximum wavelength. So red color is minimum mu. Since the red color is minimum mu, all effects of refraction will be minimum in red color. The bending will be minimum in red color. When ray goes from rarer medium to denser medium, we know that the velocity decreases. Now the decrease in velocity of the red color will be minimum. That is, if we compare the velocity of blue color and red color in denser medium, red color will travel faster. Our rule says that everything in the denser medium decreases. Velocity in medium is equal to velocity in air. Velocity in medium is equal to velocity in air upon mu. Lambda of red is more. Mu of red is minimum. All effects of refraction in red are minimum. So the bending, all colors bend. When they go from air to water or from air to glass, all colors bend towards the normal. But the bending in red color is minimum, because all effects of refraction are minimum in red. Bending in red is minimum. Similarly, the velocity of all colors decreases inside glass, but that of red decreases by a lesser amount. So, the angle of refraction for red color in the denser medium is more. The velocity of red color in the denser medium is more as compared to that of blue color, and so on. There is another experiment in which we see that objects appear to be raised when kept inside a water beaker or under a glass slab. that shift is also a measure of refraction. If we mark a blue dot and a red dot on a piece of paper and keep a red glass slab on this piece of paper, blue color will be more raised. The red color will be less raised because of the simple explanation that all effects of refraction are minimum in red. Thank you.